Okay, so artificial intelligence, AI. It's a term that's absolutely everywhere these days. But let's be honest, what does it actually mean? Well, that's exactly what we're going to tackle today. We're going to break this whole thing down from the super basic ideas to the wild, creative stuff that's happening right now. Let's dive in. So here's our game plan. We'll start with the big one. What even is AI? Then we'll sort out all those buzzwords with the AI family tree. After that, we'll get into how machines actually learn, check out the new creative AI, and wrap up by seeing where AI is already showing up in your world.
All right, first up, let's tackle the big idea.
So, what exactly is artificial intelligence? You hear it all the time, but what's the real definition? Turns out it's probably a bit more straightforward than you might think.
At its heart, AI is really just the science of making computers do things that would normally take a human brain. You know, things like learning from experience, solving tricky problems, or making a judgment call. A normal computer program, it's like a calculator. It just follows the rules you give it, step by step. But in AI, that's different. It can actually learn and adapt.
And you know, this whole idea of AI isn't exactly new. The term itself was actually coined way back in 1956, but for a long time, it was mostly just theory. We had these periods called AI winters where progress just stalled. The computers just weren't powerful enough. So the big question is, why is it exploding now? What's different today?
Well, it really came down to a perfect storm of three things hitting all at once. First, the ideas and the algorithms just got way better. Second, data. We suddenly had these unbelievable amounts of data. I mean, think about the entire internet to train these things on. And third, the hardware finally caught up. We got these super powerful computer chips called GPUs that could actually handle all that data. Put those three things together and boom, the AI revolution was on.
Okay, so all this new progress brought a ton of new buzzwords with it, right? You've got AI, you've got machine learning, deep learning, and people throw them around like they're all the same thing. They're not. So let's untangle this family tree.
So think of AI as the biggest circle, the giant umbrella that covers everything. It's the whole grand idea of making machines smart in any way, shape, or form.
Now, inside that big AI circle, you've got a smaller one, machine learning, or ML. This isn't some totally different thing. It's a way of doing AI. Instead of trying to write a bazillion rules for every single situation, you just show the computer a ton of examples and let it figure out the patterns for itself. It's like you don't tell it a cat has pointy ears and whiskers, you just show it 10,000 pictures of cats, and it learns what a cat looks like on its own.
And then, inside the machine learning circle, there's an even smaller, more powerful one, deep learning. This is a special type of machine learning that uses something called neural networks, which are kind of modeled after how the human brain works, with all these interconnected layers. The deep part just means there are lots of these layers, which lets the system find super subtle and complex patterns. This is the stuff powering most of the really advanced AI you see today.
You know, here's a great way to think about it that really clicks for a lot of people. AI is the whole concept of vehicles. Machine learning, then, is a specific type of vehicle, like a car. And deep learning, that's an even more advanced type of car, like a self-driving car. See how that works? A self-driving car is a car, and a car is a vehicle. It just gets more specific as you go down.
Okay, so we've said machines learn from data, but what does that actually look like? Let's get into the nitty-gritty of how they're trained.
All right, so two of the main ways this happens are called supervised and unsupervised learning. Supervised learning is like studying for a test with flashcards that have the answers on the back. You give the AI a bunch of data that's already labeled correctly. This is a cat, this is a dog, and it learns to make the right connections. But with unsupervised learning, you just dump a whole box of stuff in front of it with no labels at all. It's like giving it a mixed box of fruit and saying, okay, sort this out. The AI has to find the patterns and create the groups all on its own.
So, let's make this real with an example of supervised learning that businesses use all the time. Predicting customer churn. You know, when a customer is about to cancel their subscription. First, they gather a ton of data on old customers. And here's the key. They label each one as either stayed or left. Then they feed all that labeled data into the model. The AI chews on it and learns the warning signs, the patterns of people who are about to leave. And the payoff? Now they can use that model on their current customers to see who's a flight risk and maybe offer them a deal to stay.
All right, now let's talk about the type of AI that has absolutely taken over the conversation lately. Generative AI. This is a whole different ballgame. We're moving from AI that just analyzes stuff to AI that can actually create totally new things. And here's the difference in a nutshell. That analytic AI we just talked about, it looks at data and makes a prediction. It says, hey, this customer's probably going to leave. But generative AI, it takes the next step. It says, okay, let me write an email to convince that customer to stay. It doesn't just analyze, it generates.
So what's the engine driving this whole creative explosion? It's something called a large language model, or LLM. And when we say large, we mean it in two ways. First, they are trained on an unbelievably massive amount of text, like a huge chunk of the internet. And second, the models themselves are huge, with billions of connections inside them that are storing all the patterns and information they learned from that data.
Now here's a key little detail to understanding how these things work. LLMs don't actually see words the way you and I do. They see tokens. A token is the smallest unit of text for them. It could be a whole word or just part of a word. For example, the word running might get split into two tokens, run and ning. It's a clever trick that helps the model handle language way more flexibly.
So what was the big breakthrough that made all this possible? It's a piece of tech called the transformer, and its secret sauce is a mechanism called self-attention. Now, that sounds complicated, but the idea is simple. It lets the model look at an entire sentence all at once and figure out which words are most important to which other words. So in a sentence like, the truck was late because it got a flat tire, self-attention is what allows the model to know, with certainty, that it refers to the truck. That ability to understand context was a total game changer.
Okay, so we've gone through the concepts, the family tree, all of it. But where do you actually see this stuff in the real world? Let's talk about where AI shows up in our daily lives.
Honestly, you're probably using AI way more than you even realize. When you use Google Maps to dodge traffic, that's AI. When Netflix uncannily recommends the perfect show to binge, that's AI. Siri or Alexa understanding your question? AI again. Even the spam filter in your email, the product recommendations on Amazon, the posts you see on social media, it's all powered by AI working silently in the background.
Of course, all this incredible power comes with some really big, important questions we have to wrestle with. For instance, if an AI learns from data created by humans, what happens when it learns our biases too? And a lot of these complex AI models are like black boxes. We get an answer, but we don't always know how it got there. That raises huge questions about data privacy and, who's responsible when an AI gets something wrong. These are the tough challenges we're facing right now.
And really, that brings us to the biggest question of all. It's clear we're getting really, really good at making AI intelligent. But the real challenge ahead, the thing that's going to define our future with this technology, is figuring out how we make sure it also becomes wise.